Hello everyone, welcome to Module 11 of Climate Change course. In this module, we will learn about the issue related to solar energy, which is considered as one of the most important renewable energy resources that provide alternative for fossil fuel energy and also provide a great potential for climate change mitigation. So in general, in this module, you will learn about several topics which include the importance of renewable energy and the available resource. Then you will also learn about the solar energy and its potential for climate change mitigation, as well as the available solar energy technology and the environmental and social impact of solar energy technology. So after completing this module, you should be able to describe about the renewable energy resource and their importance for sustainable development. And you should also be able to discuss about solar energy, which include its potential for climate change mitigation and different type of solar energy technology. And finally, you should also be able to elaborate the socio-environmental impact of the solar energy technology. So I believe everyone know that what renewable energy is, but just in case if you don't know, renewable energy refers to the energy that is generated by natural process and that can be replenished naturally and continuously. So generally, renewable energy exists in various forms, including solar energy, bioenergy, wind energy, hydro energy, geothermal energy, and also ocean energy. Some of this type of energy is somehow depending on the sunlight in one way or another. So for example, wind and hydro energy are induced by the differential solar radiation on the Earth's surface that lead to create wind circulation and hydrology cycle, which are the driver for wind energy and hydroelectric energy. And on the other hand, solar energy is the direct conversion of sunlight and solar thermal using panel, heat collector, or other technology. Then the other renewable energy that do not depend on sunlight are the geothermal energy, which is the energy that draws from the earth core, and the tidal energy, which is the conversion of gravitational energy. So in fact, all sources of energy, either renewable or non-renewable, are important for us. They provide both benefit and also negative impact, though the impact level can vary considerably between different sources. And generally speaking, the world is more concerned about the impact of using non-renewable energy, such as fossil fuel, including coal, oil and gas, as well as nuclear, than the renewable resource energy. Because using non-renewable energy resource can result in tremendous negative effect on our climate and environment. So for instance, you may also aware the harmful environmental impact of fossil fuel and nuclear plant. For example, the impact that resulting from various accidents such as oil spill, coal mine disaster, and nuclear meltdown, such as the case of Fukushima nuclear plant that has just happened in recent years. This accident have led to significant loss of life and economic resource, as well as pollution in a vast spatial scale. And additionally, even without any accident, using non-renewable resource or energy, especially fossil fuel, can also result in environmental impact that involve air, water, and land pollution. These impacts are commonly less obvious, but it is ongoing and can cause potential damage to both human and ecosystem. Then in terms of climate change, fossil fuel combustion is the main source of anthropogenic greenhouse gas emission that lead to rapid increased global warming. So in that sense, avoid using fossil fuel could be an effective way to mitigate global warming and climate change as a whole. Furthermore, quite apart from climate change and the environmental impact that we had discussed earlier, another reason for us to reconsider about the use of non-renewable energy source is not going to be available forever. So with the increasing energy demand due to economic and population growth, they may be running out very soon. So for this reason, we have no choice but to shift away from non-renewable energy to the renewable one. This slide presents the share of different energy sources and the global primary energy supply in 2008. So as you can see here, currently our available energy sources include both the non-renewable and renewable one. Although this data presenting the situation in 2008, but today's situation is not much different, which means that our current global energy system is still dominated by the non-renewable fossil fuel. So somehow to be able to avoid problems that may caused by lacking of energy supply, as well as to protect our environment and mitigate climate change, this pattern of energy supply is needed to be reversed. According to the International Panel on Climate Change, to mitigate global climate change, greenhouse gas emissions must be cut down by 60% by 2050. And to meet this target, the global energy pattern needs to be shifted to based on various types of renewable energy resources. So as you can see in this figure, in particular, our future global energy system needs to rely more on the renewable resources such as solar energy, wind energy, and also many other types of the renewable source energy. Now let's discuss about solar energy. So basically, solar energy is the energy that derives directly from the sun. It is the most abundant of all energy resources, which will never be exhausted. Particularly, the amount of solar energy that is intercepted by the Earth is about 10,000 times greater than the rate of current global energy demand. However, the amount of solar energy that could be put into human use depends on various factors, including the location, land availability, meteorological conditions, as well as technological availability. In addition, due to the inherent variability of sunlight, solar energy is most useful when it is integrated with another energy resource to be used when the sunlight is not available. This figure presents the technical potential of various renewable energy resources, including solar energy, compared to the global primary energy supply in 2008. So as you can see here, the technical potential for solar energy technology to supply energy service alone can already surpass the current energy demand. This means that advancement of solar energy technology will provide a great potential to eliminate energy demand from fossil fuel. It is therefore a potential measure to mitigate greenhouse gas emissions. And furthermore, in addition to this greenhouse gas mitigation benefit, the use of solar energy technology also positively influence on the human being and environment in a variety of ways, which include reduce risk of air pollution and improve environmental quality, increase regional and national energy independence, create new job opportunity, especially in the solar energy technology area, and also enhance rural livelihood by increasing energy provision in the rural area, particularly in the developing country. So now let's move on to the available solar energy technology. So in fact, solar energy have been used since the beginning of our civilization, though it was used in a more conventional way, such as direct solar drying and heating. But our human capacity to draw energy from the sun has already been in progress. Then step by step, we are capable to convert sunlight or solar thermal into different forms of energy through various technological options. And currently, a wide range of technology are available to convert sun energy into various forms of energy service and application. Those technology options include the passive solar and daylighting technology, active solar heating and cooling, photovoltaic electricity generation, concentrating solar power electricity generation, and solar fuel production. So we will discuss about this option one by one in the next several slides. So let's begin with the passive solar and daylight technology. Basically, passive solar energy technology is a type of technology conversion that solar energy is absorbed, stored, and distributed in a natural manner without using any mechanical element. And one of the more common examples of passive solar system is the natural heating system, which is designed for building, and you can see in this image. And for such a system, appropriate building design and material are used as a means to convert sunlight into heat energy that keep the building temperature warm. Then for the active solar heating and cooling technology, active solar heating and cooling technology are the technology that use the sun and mechanical element to provide either heating or cooling service. Presently, various technologies are available, which include solar heating, solar cooling, and thermal storage technology. Solar heating technology is the technology that converts sunlight into heat energy using solar thermal collector to provide heating service. Currently, this technology is the only suitable option to use in industrial process that require low to medium heating temperature. This technology particularly very useful for the process that need large amount of medium temperature heat, such as large-scale desalination and water treatment process. On the other hand, solar cooling technology is the technology that uses solar thermal collector to generate cooling from a heat-driven chiller to be used for refrigeration or air conditioning. And one of the great examples of this technology is the solar refrigeration that is used to cool store vaccine in the peripheral health center in remote area where electricity is not available. Then the other technology is the solar thermal storage technology, which is the technology that collects excess thermal energy from the sun and store it in the storage medium for later use, either to provide heating, cooling, or convert it into electric power. So moving on to the photovoltaic electricity generation technology, or shortly called the PV technology. Just like what it is called, the PV system generates electricity from sunlight or photon energy through the photovoltaic effect. This system generally composed of solar panel for absorbing and converting sunlight into electricity, a solar inverter for converting the output electric current, and several other accessories for storing and distributing the power. And for the modern PV system, it may also include solar tracking device to minimize the capacity to capture sunlight from every angle. And currently, two types of the PV system are available. This includes the grid-connected system and off-grid system. The grid-connected PV system is the system that connects and provides power to the utility grid, which can be a distributed system that made up of a large number of small local power plants, or a centralized one that works as one large power plant. Then in contrast, the off-grid system are typically the standalone system, which generally require an electrical storage element or backup power. It can provide relatively small power capacity and is connected to electric appliance directly. One of the advantages of this type of PV system is it allows easy mobility. Up to now, the PV system has been used in a wide range of applications. For example, the grid-connected system are used to power household appliances directly or transferred to a power grid, which is then distributed to various appliances such as lighting and other devices as needed. These systems are more commonly used in house or commercial buildings to offset the electricity cost. Then for the off-grid system or standalone system, it is more applicable and very useful for small energy demand and in some urgent situations, such as during disaster release, and also used for lighting in remote area where the other source of electricity supply is generally not available. Okay, now let's move on to another type of solar energy technology, which is the concentrating solar power electricity generation system, also called the CSP system. The CSP system is a bit different from PV system. So while PV system use photon energy or sunlight to generate direct electricity, the CSP system use solar thermal concentrator to convert solar energy into heat, and then the produced heat is converted into electric power. So generally, the CSP plant use mirror or lens to concentrate a large area of sunlight or solar thermal energy into a small area. The electricity is then generated when the concentrated light drives a heat engine, such as a steam turbine that connected to an electrical power generator. So in the CSP system, the thermal energy concentrated can be stored and used to produce electricity when it is needed. This technology is commonly used in power plant together with some other form of fossil fuel burner to increase the amount of thermal heat source. Nowadays, there are 4 types of the CSP system, which are mainly different by the type of thermal collector. This system includes the linear Fresnel, parabolic trough, tower, and parabolic disc. So as you can see in the figure on this slide, the linear Fresnel and parabolic troughs are kind of linear focus collector, while the tower and parabolic disc are kind of the point focus collector. Then the latest solar energy technology is the solar fuel technology or solar fuel production. Solar fuel technology is the technology that uses solar energy to generate chemical fuel such as hydrogen, synthetic gas, and liquid, which include methanol and diesel. Solar fuel, particularly the hydrogen, is viewed as the future of energy supply alternative to fossil fuel, because unlike the other type of solar energy technology, solar fuel technology allows production of solar fuel wherever sunlight is available, and the produced energy can be stored, transported for later use wherever needed. So from previous section, you have seen a lot about the technological option and application of solar energy technology. And I believe you also learned that solar energy technology provides a wide range of advantages, including potential for climate change mitigation and alternative choice of energy supply, especially in case that non-renewable energy resource such as fossil fuel is not available or inadequate. Somehow, just like other type of energy source, along with these advantages, solar energy technology can also bring about some concern involving the negative impact on the environment and society, though the impact level is much smaller compared to the consequence of using fossil fuel. So for instance, the negative environmental impact of solar energy technology includes some minor concern about air, water, and soil quality, as well as land use change and ecosystem variation. Then for the social system, the negative impact of solar energy technology on social system is generally not significant. In contrast, it provides many benefits, which include improvement of social welfare, for example by increasing access to power supply, reduce exposure to air pollution, and so on. Then another important benefit of the solar energy technology on our social system is the provision of new job opportunity, especially in the energy sector. So now it comes to the end of the module. I hope you enjoyed the lecture, and you should have learned that renewable energy resource is very important for climate change mitigation, and particularly solar energy, which can be derived by various technological options, including passive and active one, can provide a great potential for mitigating greenhouse gas emission, as well as provide socio-economic benefits that support sustainable growth of our society. And along with this, you should also have learned that solar energy technology also brings about some minor environmental concerns, such as the indirect impact on air, soil, and water quality, and the effect on land use change and ecosystem variation. So now we can call it a day, and I will see you again in the next module.